It's not too bad. You have a tangent to the fifth. What I would do is save one tangent, tangent of x over 4. We probably should change everything to u's to make it easier here in a minute. That would be tangent squared of x over 4 squared. So it's tangent to the fourth times tangent, which makes tangent to the fifth. I believe I'll turn it into u's right now. Tangent of u times tangent of u, tangent squared of u squared du. By doing this, I'm letting u equal x over 4, or 1/4 x. The derivative on the left is du, the derivative on the right is 1/4 dx. So you might need to multiply by 1/4 to create the du, and by its reciprocal out front, which is a 4. It's usually best to change everything to u's when the angle is not simply x or theta. Now, I'm going to keep the integral, I'm going to keep this one tangent. Tangent squared, there's an identity. 1 plus tangent squared equals secant squared. So tangent squared could equal secant squared minus 1. So this tangent squared in here I'm going to replace with secant squared minus 1. When you square a binomial, you square the first, twice the product in the middle, so that would be minus 2 secant squared of u, square the last. So you square the first, square the last, and twice the product in the middle. Now if I distribute, I'll have secant to the fourth u tangent u, that's this first one, times, or let's see, minus 2 that is, secant squared u tangent u, and tangent u times this 1 on the end would be plus tangent of u. Now this is like the previous problem. The derivative of secant is secant tangent. You have a tangent, so if I pull out one secant, this 4 applies to everything, so I'm just going to keep it out front and make multiple integrals. If I factor out one secant, that would leave me secant to the third of u, secant u tangent u du, minus 2, again I'm going to make another integral. The derivative of tangent is secant squared, so I may do tangent of u secant squared u du, and this last integral is just the integral of tangent of u du. So I'll keep my 4 out front. This is u to the third du. This is another u. This time I'm letting u equal secant. The derivative of secant is secant tangent. So this is like a u to the third, and all of this becomes the du. So when I integrate that, it becomes u to the 4 over 4. This next one, the derivative of tangent is secant squared. So if I let u equal tangent, du is secant squared. So this one would be minus 2, and to integrate you raise the 1 higher and divide by the 1 higher. The 2's should cancel. Plus, over here I have the integral of tangent of u, which is just a formula. It's negative natural log of cosine of u. That's in the front cover of your textbook, or we could derive it. Tangent is cosine over sine. And to turn the top into the derivative of the bottom would require a negative. It's actually sine over cosine. and the derivative of cosine is negative sine, so it'd be du over u, which is natural log of u, with the negative. When I multiply here, I'm going to have simply u to the fourth minus 4 times over here u squared, because this 4 applies to everything. Again, minus 4 natural log cosine of u. Now I'm going to replace my u's. In this case, u was secant. So the answer should be secant to the fourth of 4x, because that was my original u, minus 4. In this case, I'm letting u equal tangent, because derivative of tangent was secant squared. So I believe this would be minus 4 tangent squared of u, which would be 4x, minus 4 natural log absolute value of cosine of 4x, again plus c because it's an indefinite integral. Now there are multiple forms that are equivalent. You could have left this in. Hopefully this helps with some of the trig problems.